Okay, so as usual, we are going to start with the exercises that you did over the week, just to get sure you didn't make any mistake. So the first thing I'm going to do is, this is the link I gave to you. I'm going to increase the font a bit. As usual, you know, you have to go to File, save a copy in Drive. And now you can open that copy and you can play there. Because here we are already dealing with a corpus, even if this particular corpus contains one single file. The first thing, remember, you have to do is you need to open this folder here. Now it is connecting to the runtime, which is in the Google Cloud. Right-click, upload, and you can upload your corpus, which in this case is file Genesis. So now that you have Genesis uploaded, you can play with it. So I'm going just to scroll down to the beginning of the exercises. Before I begin with the exercises, is there any doubt about the contents that we covered last week? Okay, no doubts. So exercises. It says, first of all, load the corpus and store it into a variable we name txt containing a list of all the lines in it. And I told you to scroll up and see how to do it. So I can make txt with open the name of the file, with reading permissions, and that's very important, as the name of the variable. Let's call it file do. So the name of my variable is going to be txt, and it's going to be equals to file dot read lines. And read lines is going to give me this list containing every single line in the file. If I want to get sure, well, sorry, I already gave enter. If I want to get sure I'm actually getting what I'm supposed to, I can print, let's say, the first 5 lines. So I have line 0 is the book of Genesis, line break, 1 empty line, chapter 1 empty line, sorry, line break, another empty line, and the first string. So yeah, this one is covered. It's fairly trivial. Now let's go to the real exercises. So the first one was create a list containing only those lines in the corpus, including substring GH. You sent me a number of solutions, which most of them were correct. The one I'm going to show here is just another one of them. So here I'm going to create a list, and I'm going to say x for x in my variable if this line x, sorry, if the string I'm looking for in the line. And that's it. And to get sure I didn't make any mistake, once again, this time I'm going to print the first 10 lines. So let's execute it. Light, there is GH here. Light, there is GH. Light, well, most of them apparently is always light. Well, there is, where is it? Yeah, it looks like every single time it's light. Oh no, here it's broad. So many of you decided to go for a regular expression. So you actually compile a regular expression trying to find out instances of GH, and you did a loop over the list that you had generated, over the txt list. This one is just another way of doing it. So just to get sure we are all understanding what I'm doing here. I'm iterating. If we focus on these for, let me just to get sure you all look at this properly. So this is a for loop and nothing else. For x in my list of sentences or my list of lines, I'm going to do some operation. The operation is going to be an if. If the string I'm looking for appears in the current line, then I'm going to store it in the resulting list. So this one-liner that I have here is equivalent to do it for x in txt if gh in txt lines with gh dot append x. So these three lines and this single line are identical. The result is identical. This one is nicer. It's a bit more efficient, and it's more clear to an eventual reader of your code. Is there some doubt about this?
I have a doubt. So here you're looking for like two letters, like an exact string. Can you have a regular expression instead of the exact string in that matching expression?
Yes. So this is an if, and the result of this is either true or false.
Okay.
So it operates identically to this. If instead you insert a regular expression here, you can also get true or false. So yes, you can insert a regular expression here. Okay. In this case, it's super simplistic because it's, as you say, it's a specific string, 2 characters. If instead you want to look for a specific regular expression, you can add it here in the if.
Okay. Without any need for re.findAll or that kind of...
No, of course you have to compile your regular expression first.
Okay.
Yes. So here, this is just an operator, in. So if here I could say, for instance, equals, just to say something. This is just a Boolean operator, which is going to give me true or false. And if you want this condition to be a regular expression, then you need to compile the regular expression before you need to define it, and then you can apply it here.
Okay, so it doesn't work, so that only works with exact strings, not with regular expressions.
The one that I use, this one, yes. Okay. So it goes over the full string, and it tries to find if these 2 characters appear there. Yes, a regular expression would be another way, probably more elegant, but in this case, I don't need to compile it.
Okay.
Because I'm taking advantage of a string operation. Now here, the second question is create a list containing only those lines in the corpus, not including this substring. So the only thing I'm going to do is I'm going to copy this line here, and the only thing I have to say is not in X. And let's see what happens. Oh, here it is already. So let me just print the first 10 instead of all the instances. So here you can see if we just compare the first 10 instances here. Oh, this thing didn't work. Yeah, because there's a mistake here. I'm using a wrong variable. I'm printing I was printing the same line here, the same variable here. So when I print the right one, which is the one I just produced here, instead of starting with the got say, blah, blah, which actually has GH appearing here, in this case, the first line is the book of Genesis, which do not contain GH. Is this the full story? Well, not really. You can add many different variations. For instance, one thing you could do here is add lower here. So in this case, you are not looking only for lowercase gh. You could also find uppercase G, lowercase h, or uppercase both G and H. Okay, so this, as I said, some of you were asking related questions. So this is under-specified because I just said, okay, I want strings with GH. So one natural question would be, do you want also uppercase GH or only lowercase GH? So this is extra. And that would cover exercise number 2. Questions about it? Okay, let's keep going. Exercise number 3, create a list containing only those lines in the corpus ending with eng. So the naive approach to this would be, again, copying this. And here we could write X ends with eng. Is this the best option? Probably not, but I just want to see the result. I'm reusing the same variable because I don't really care about keeping it, and I know the naming now has nothing to do with what we are actually doing here. It doesn't matter, it's just a variable. So once again, copy, let me just print the first 10 instances and see what happens. So apparently, according to this command, I'm not getting anything. So the question here, I mean, I'm doing these mistakes on purpose just because I want to show you what's going on. There is a problem here. If we look at the corpus, every single instance in my list ends with line break. And line break, which is defined by this \n, is one character. And this is why there's no single instance ending with ing. All the instances here end with \n. If I write here \n, I get all the corpus. So there are many ways to deal with this issue of ending with ing. One of them would be saying, this is the suffix I want to recognize, and for some reason it doesn't get anything either. There might be many reasons for that. One of them is, for instance, that all of them end with not only with ing \n, but they might also end with a punctuation mark, either a comma or a dot. So let's say, let's have a look and see if I can capture something with ing period. And yes, we do. So for instance, this line, no te preocupar. For instance, this line actually ends with a period followed by \n. Is this an elegant way to do it? No. The best way here, well, there are actually two best ways. One of them is stripping the string before looking at it. Stripping means it's a function. Let me open a new code snippet. Let's say my string, I'm just going to call it randomly. String is equals to whatever, space, tab, \t means tab, space, \n, which is line break. If I just print kk, this variable, you don't see it here because spaces are, let's say, transparent. But as you can see, if I try to highlight it, here I have the spaces, the tab, and the \. So to make it evident, I'm just going to add an X here. And you can see it here, right? So we have a line break at the end, and afterwards an X. Going back to the original string, if I print kk, but I apply a strip, the ending spaces are not here anymore. G is the last character of my string. Let me get rid of this for a while. If my string actually looks like this with a bunch of spaces at the beginning, you can see all the spaces are here. If I bring back the strip, there are no more leading spaces. So strip is a very convenient way to clean strings that usually or often have spaces at the beginning or spaces at the end, which in general are not informative and are useless. So with a strip, we will deal with the \n. But again, there are cases which end with a period, with a comma, with a semicolon. In that case, it would be much nicer to use a regular expression here as the one that was suggested before. But I'm not going to do it here because I don't want to wait so much time. So basically, the regular expression would be something like ing, which is the sequence that we are interested in at the end, followed by 0, 1, or more occurrences of punctuation mark, followed by 0, 1, or more occurrences of space or tab or line break. Are we fine? Okay, I hope we are fine. So now start from scratch, read the corpus into a variable txt containing the full corpus as a single string. So I'm going to copy what I did here. No, I don't want to copy the cell. I just want to copy these 2 lines. I didn't copy. Copy selection. So now I have, instead of doing read lines, I'm just going to use read. So as a result, I don't have a list anymore. Now I have a huge string with the full genesis. So that's why when I try to slice it, I don't get the top 5 lines. Instead, I get the first 5 characters. Or yeah, the first 5 characters. So if I write, I don't know, 50, 55, I get an error because I deleted the square bracket. And now I have the first 55 characters. So it's just a very slight difference, but the change is very significant. Now, I already have this, and the question is, how many uppercase tokens exist in this? So once again, what I have to do is I need to apply a regular expression because I'm lazy and I know a solution very similar to this is already here. I'm just going to copy it. And here I do have to compile a regular expression. So the first thing I'm going to do, I'm scrolling back down here. Okay, I delete this one. The first thing I need to do is I'm going to import my library. This I did it already, so I don't need it anymore. And here I had a regular expression to recognize all combinations or all sequences of uppercase letters, lowercase letters combined 1 or more times. So the question now is how many uppercase tokens exist. So this is what I have to do. And then the question is, how many do you have? Well, then I need to write the length of those tokens, and there are 5,431 of them. If we want to see if what we are doing is correct, which is always very important, we can print them. So the book of Genesis, they are all words with only uppercase. This, I'm not sure what this is. I guess there is some numbering, some odd numbering in the file. But then afterwards, we start finding once again full words. One important thing here is that we don't have here we have tokens, which means every single repetition counts. If instead we want to know the size of the vocabulary, something we can do is we can make this a set. And unless I do something wrong, there are only 30 unique words which are composed only of uppercase characters. Is that clear?
Not really for me.
Okay, tell me, what's the problem?
What exactly that set bit is doing?
Okay, so let me try something to clarify it. Before that, something that I want to clarify. Here, or better said, here I'm getting a list of tokens. And I told you, a list is just a sequence of things. In this case, the sequence is a sequence of strings. So it's roughly this. This is what I'm printing here. Here I'm applying a function to that list, which happens to be called set. But I'm not altering the tokens. If here I print again, let me do print, because otherwise the Jupyter Notebook only shows the output of the last command. So we print this len, and here we're going to print the len of the list itself. This is also related to a question that I saw during the week. Tokens remains the same. I still have 5,431 elements. What is set doing is set and as in set theory. So it's a collection of things in which elements appear only once. So for instance, if my list is equals to, let's say, 1, here's the comma, 2, oh well, I'm going to do 3, 4, 5, 6. If my list is like this, notice that I have 2 here and 2 here. I have 2 repetitions of the same element. If to this I apply a set, what's going to happen is that all repetitions are going to be discarded, and I only get the first instance. So if I print list here, if I don't get set, which sometimes happened, sometimes happens, sorry. So this was my original list, and this is my set. I don't have 2 twice. I only have 1 occurrence, because that's the definition of set. It's a collection with only 1 occurrence of each element. So that's what I'm doing here. I'm getting the vocabulary.
It's a bit like unique in Bash.
Correct. Okay. It's like unique. With the difference that unique in Bash operates at the line level. So 2 identical lines, one next to each other, are merged into one. But if you have 1 line in row 1 and an identical line in row 50, it's not going to do anything.
Okay.
In this case, it doesn't matter. If you see 2 appears in cell 1, and this second 2 appears in 1, 2, 3, 4, 5, in cell 5. It is like a bag. But in this bag, when you drop something in the bag, the system looks if you have something like that already there. If it's not there yet, it takes it. It grabs it and keeps it in the collection. If it looks that it already exists there, then it's rejected. So this is a very simple way to find the vocabulary in a corpus. So you just tokenize, and then you apply set, and you get the vocabulary. In particular, here I'm getting the vocabulary of uppercase letters. So here, if instead of printing the length, which is going to give me 35, I just print the token, sorry, with an S. This is my vocabulary of only uppercase letters. Sorry, words. Only 30 words. Notice I'm not using the linguistic definition of word. To me, this is a word and this is a word, even if it doesn't make sense. A better way of calling it is actually tokens. So indeed, talking in terms of computational linguistics, these are the types in my corpus. Is it more clear now?
It is for me.
Okay. I hope for everybody else as well. So if you have doubts, just stop me and I can explain further. So unless you stop me, exercise 5. How many 4-letter words exist in this version of Genesis? So once again, I'm going to reuse. You know I'm pretty lazy, so I'm just going to reuse this. Now I do care also about lowercase letters, so I'm going to add this. As far as I remember, I don't need, no, wait. It's wrong, it's like this. So now I have my full regular expression. Let me go up because I always hesitate with regular expressions. I'm not a super big fan yet. It's correct, it's like this. So with this regular expression, I go back. Yeah, I'm here. So I get every single word. Another question is how many letter words exist in this version of Genesis? Once again, there are many different ways to do this exercise. So I'm going to show you one of them. Because I have a counter, I'm going to initialize a variable, which is going to be such a counter. Usually I is a typical name for that variable, but you can call it as you wish. And then I can do a for x in tokens, do something. What I'm going to do is I'm going to count those tokens with length 4. So I'm going to do if the length of x is 4, I'm going to do I equals, no, sorry, plus equals 1. And finally, I'm going to print I. Okay, so let me execute it. According to my operations, there are 7,829 words with length. So I just want to get sure you all understand what I did. Here I have a list of tokens. So here I'm iterating over that list. Once I get every single token in that list, I have an if. If the length of such a token is 4, then I increment the variable of my variable I by 1. And finally, once the loop is over, once I've been through all the tokens in my list, all the tokens in my corpus, I just print the output. This is one way to do it. There are many other ways to do it. For instance, I could have, let's say, let me call it letter 4 equals, which is something similar to what I did before. It's equals to x for x in tokens if length of x is equals 4. And if I print the length of letter 4 and I didn't do any mistake, I'm going to get the same value. All right? Question, which one is better? So in case the question is not clear.
One.
Sorry?
The second one, maybe.
The second one is better. Why?
Because it's more simple.
Okay. Does somebody vote for the first option? I mean, this one here. Nobody, I'm surprised. Don't be shy. So
maybe the first one is more easy to customize if we have to change. I mean, if you have to do like a similar task, but not the exact same one.
Okay. Yeah, that also makes sense. So there's no black and white answer here. There's no 100 correct and 100 wrong answer here. Both instances have advantages and disadvantages. Let me start with the second one because this is important and this is about computational thinking. So you say, some of you say this one is simpler. Yes, in terms of reading the code, it looks simpler. But I'm afraid computationally speaking, it is not simpler. Let me tell you why. Here, I'm creating a list with a few thousand strings. Here in this line, I'm creating a second list. So I'm using more memory here. If my purpose is just getting this number, and I don't care about the contents of the list, and I'm not going to use it later, this one is much from memory. I'm just iterating over the list, and I'm getting the final value, which is the exact value I need and nothing else. If instead I do care about the contents, I do care about the subset of tokens in my corpus with 2 characters, then definitely this one is better. Because actually here I'm not getting that list. In this case, I would have to create my variable here, an empty variable, like this. And here I would have to do letter for append, and I would append the list. So with these 2 extra lines, I would get a variable identical to this one. Was that clear? These kind of things are probably here in this particular example, it looks silly because it's so simple, it's just 5 lines of code. But imagine you are not dealing with Genesis, you are dealing with a corpus with, I don't know, 5 million news articles, or more, 10 million, 20 million news articles. These kind of details start to matter. And rather than having a corpus which runs, let's say, in 2 minutes, it might run in 5 hours. And that's a huge difference. Is it clear now?
Alberto, can I ask a question?
Yes.
Sorry to ask many questions. Why do you need that in the second version? So x for x in tokens if. So if you just have a for loop, you can write for x in tokens. If you write it like this, you need to add the extra x at the beginning.
Yes.
Why?
This extra x in this one-liner is the value which is going to end up in the final list. So if I only write this, I'm not sure if it's going to run, but let's try. It doesn't do anything because I'm telling basically what I have here is identical to these 2 lines. And the purpose of the x here is, x is what I'm doing. It's not exactly this, but it's the body of this if. So any operation I have here is what actually is going to end up in the final list. So that's why I have x for x. So this x is each of the values that variable x is going to take in the loop. So this is equivalent to having the x here, which should be the letter4.append. So what I'm doing, what I was doing before, letter4.append x it's this part of the loop. And I can do many operations here. For instance, I could do x.lower, for instance. Or I could do x plus, to make it more more evident, let me do x plus, I don't know, 1, 2, 3. And let's print the first instances. See? So this is in every single iteration, I do something to this string. In this particular case, before I wasn't doing anything, I was just storing it in the list. Here, I'm even adding something. I could also do lower before, and I get the lowercase version of it. Did I answer why we need for x?
Yes, perfect, thanks.
Great. Yeah, please keep asking questions. It's even better. I don't care if we stay here. I mean, I hope you are finding this interesting. I think it is. So it doesn't matter if we stay in these exercises. Okay, how many words contain only vowels? Well, it's something very similar to this. Let me copy the regular expression. So now I want something like this. And the question is, how many of them do have only vowels? So I can reuse this. No, wait. No, that's it. I have 47,124. Let's print a few of them to get sure I didn't make any mistake. Yeah, I didn't make any mistake apparently. So it's quite simple, as you can see. This is definitely not rocket science. By the way, I'm doing something very, very wrong here, and I don't know if you realized. These are not actual tokens. These are all sequences of vowels in my corpus. Does any of you know what I'm supposed to do here to fix it?
I added a space on either side of the regular expression, so that way it would find things that are not inside a word but are independent.
Okay, let's try. You mean something like this?
Yes, exactly.
Okay, now the amount is very different. So let me undo, because I don't remember the amount I had before. So I had 47,124, which is basically the size of the vocabulary. If I instead I add an extra space at the beginning and at the end, I get 348. Question, is this number accurate or not?
No.
Why?
Because if the word is followed by any punctuation mark or is at the beginning of the line,
correct,
it's not matched.
Correct. So if I don't have a space here, but I have a parenthesis, if I have a punctuation mark here, like a period or a comma or quotation marks or whatever, instead of a space, I'm not counting those words. Okay? So again, I'm not going to do it here, but rather than a space, you need to look for spaces or any punctuation mark, both at the beginning and at the end. This is tricky, and one reason I don't insist on this about the spaces at the beginning and a fancy regular expression is that there are libraries available for free, which are called tokenizers. And some people made models to tokenize text properly, to deal with line breaks, to deal with punctuation marks, to deal with everything. So in the same way as here we are importing a regular expression library and we are compiling the regular expression, we can simply call the library to do tokenization, set it up for English in this case, or for Italian, or for any language, and then I just write tokenize my string, and I'm going to get the tokens. So this is why I'm not insisting that much on designing nice regular expressions, because if your language is not extremely rare, it's very likely somebody already built a proper tokenizer and it's going to work for you. For instance, so we had some difficulties some weeks ago because we wanted to tokenize text in 16th century Italian, as far as I remember. So it wasn't exactly the same Italian as it is spoken now, but it still works. So we didn't have to do any fancy regular expression. So final question, are there words without vowels? So basically here I'm not going to do it, but basically you have to do a very similar regular expression to this one, the correct version of this one, and you need to add all non-vowels instead of the vowels here. Okay, before we actually go to the topic today, it's been pretty long. Do you have any question about these exercises, about the programming concept we have covered so far today and even last week? Okay, so let's go to the lesson today. Let me start once again by making a fresh copy of this. So again, save a copy and write. You don't have a copy of this one yet, as far as I can tell, but you are going to get the link soon. So let me skip, this goes from the beginning. Let me skip to the new contents. Here, I believe. Yeah, so these are roughly the exercises we did. We are still working with Genesis. Here, I'm in a different place from the one I was at before. So once again, this is a very common error. The first thing I need to do is I want to upload my corpus again. In this case, it's very simple because it's one file and it's just a few kilobytes. If your corpus is much larger, it starts to be a bit tricky to upload and download the corpus every time, but here I don't care, it's all right. So I have Genesis already. This again is a fresh notebook. So if I just execute this, it's going to tell me, oh, I don't know what to do with this because I have no idea what RE means. So the first thing I need to do is to import my library, because these are two completely independent Jupyter notebooks. So I still get an error, but just let me, before going to that error, let me show you what I'm doing here. So the task here is I want to find words which appear more than K times in the corpus. So what I'm doing here is I'm opening a fresh copy of the corpus. This is actually not what I'm doing. Wait. I get a fresh copy of the corpus. Let me copy this into, wait, because this code is not what it's supposed to do. So let me just add a new code snippet here and keep it temporarily there. And I'm going to delete all of these. Yes. So the question is, get the K most common words. So I first read my corpus, and txt is equals to input dot read. And now I need to once again tokenize the text, so I'm going to just copy it from here. I have the tokens, and what should I do to count the tokens in my corpus? Do you remember? No? So there were two ways to do it. One of them is I can use a dictionary or I can use a counter. So I'm going to use a counter. Let me scroll up and copy all the code for the counter, because in that way I don't need to do anything. And we are back here. So the first thing I need to do is I need to import the counter, and then here. Oh, sorry. This one here, and this one right here. So I import my counter. I find the tokens in my text, and finally I count them. So the question here is get the k most common words. So what I can do now, if I just print this, I'm going to get every single word regardless of the frequency. So the most frequent ones here, and if I go at the end, I get all hapax legomena, which are the words appearing only once. So if I want only words, let's say, appearing at least 5 times, now I need to iterate. That's one option. I need to iterate over this counter. And if the value associated to the counter is higher than this k, I'm going to grab it and I'm going to include it in my list. Probably not the most efficient way to do it, but let's just do it as like this by now. So I can create a dictionary, empty, and then I iterate for key in my counter if the value associated to, sorry about that, the value associated to that key is bigger, oh sorry, wrong key, it's bigger or equals to k, then I'm going to add a new value to my dictionary, which is going to be x, and the value is going to be c of x. And if I didn't do anything wrong, and now I print d, so this is my original counter with all instances, and these are only those tokens in my collection which appear 5 or more times. So to make this a bit more dramatic, let me do, or a bit more clear, let me do 50. So now I have only those tokens appearing at least 50 times. Okay, this is a fairly simple way to get rid of stop words, for instance. Because as you know, stop words tend to appear very often. So let's say you are, again, working on a kind of atypical language, not so common language, and you don't have a list of stop words to get rid of. You can just get the most frequent ones and you drop them. Is this clear? If instead you are interested you're interested, sorry, in the most rare words, you can modify this a little bit and you can do lower or equals. And let's see, these are the words appearing only once in the corpus. So enmity, belly, pangs, childbearing appear only once in the in Genesis. Okay, so once again, the take-home message for this is a couple of modifications, change the behavior completely, which is very handy because you might want to do some similar things, and you just need to change a bit the code. So in this second experiment, which is already coded, the task is getting all the n-grams appearing k times and only k times. So I'm not referring to words anymore here. I'm referring to n-grams. So the first thing I need to do is getting the n-grams. But if you remember in the last lesson, I did have already a function to compute n-grams, which had two parameters. The first parameter was the list of all my tokens, and the second parameter was the size of the n-gram. If I execute this right now, the Jupyter Notebook is going to tell me, I have no idea what this means. So you are calling something called n-grams, which apparently is a function because you have parentheses afterwards with the parameters. I don't know what to do with this. So again, I'm just making this mistake on purpose to show you that I do have an n-grams function. If I scroll up, it is here somewhere. Here it is. But if in a new session I don't execute this block of code, it doesn't exist to the Jupyter Notebook. This is just text right now. So I need to first execute it. And now this method or this function exists in memory, and I can call it. So in case you find this kind of mistake and you are kind of lost and you don't know what to do, remember, everything in your Jupyter Notebook, or better say nothing, is loaded from scratch. You can run everything at once. But if you don't do it, or you don't go and execute that specific block of code that you need, you're going to get an error. So now that I have my function defined, I can scroll back down and I can use it. So now I get the n-grams. In this case, notice that I have defined n equals 5 here. So I want to get 5 grams. I get the 5 grams here. I count them, which is identical to what I did before. And now I want only those 5 grams appearing k times in the corpus. Remember that I showed you here a very kind of verbose way to do it. Another way to do it, a way to get the subset of those n-grams, is something similar to what we did before. I create a one-liner, which is going to produce a list. And the list is going to be produced as follows. I'm going to iterate over all the n-grams. And if the value associated to each of those entries is equals to the one I want, this k equals 5, which in this case is the counter, I do add it to my n-grams. And finally, I print it. So 1, 2, 3, 4, 5 tokens, 1, 2, 3, 4, 5 tokens. So these are the word 5 grams appearing exactly 5 times in my corpus. Is that clear? As you can see, for instance, here, if we want to explore the corpus, it's obvious that, and it was so good, and God saw that it was, so that it was good. So these are phrases that are repeated over and over again in the corpus. And God saw it was good, and then blah, blah, blah. That's why they appear so often. Is there something shocking in this code, something that you didn't like? For instance, I'm showing this to you explicitly. Is there something that I shouldn't do here. Okay, if nobody wants to mention it, notice that here I have a method called ngrams, and the output of ngrams, I'm storing it in a variable called ngrams, and Python didn't complain about it. So what happens if I execute this again? It's going to tell me this list is not callable. Why? Because I just overread the definition that I had of ngrams. Ngrams in this particular moment is not a function anymore. Now ngrams is a list. It's the list that I just computed before. So be careful with these kind of issues. If you're going to have a function, or be careful with the naming conventions. Never override a function, and you're not going to get access to it anymore. So if I want to access this again, I need to go back to the top of my code, and I need to execute once again this code snippet. So once I do this again, ngrams is once again this function, and I can call it again, but I don't have the list anymore. I lost it. So if I want to use that list again, I need to execute this again, but this time I'm not going to call it ngrams. I'm just going to call it, I don't know, whatever name. And here I need to update it, and I need to use that same name. And now I can execute this as many times as I want. So if I want to get 10 grams appearing at least 5 times, not 10 grams appears 5 times. Maybe, I don't know, 7 grams. And got so that it was good appears exactly 5 times. Do you have some question about this? Did I lost you, or everything is crystal clear?
I think everything is clear. I had a question about functions. Like, for example, if I define a function, like in this case, I don't know, ngrams that we defined first, and when I'm working on another document in Colab, I want to use that function again. Is there a way to create like my library of function that I defined in the past so that
Absolutely.
I can reuse them?
Yeah, that's a very nice question, and it's very timely actually. So what we are doing here is basically working with this interface that is Colab. There is another way to use or to create a library, which is actually the name of these other code snippets, which I can create once and just load them from here. I don't intend to cover it here, but basically what you do is, on top of adding a TXT file here, you can also upload a Python file, which again, I'm not going to do here. And you load it in the same way as I'm loading this library here. So let's say my Python file is called file.py, just to give an example. So I will do from file import and the module that you want to load from that file. Let's say it's ngram. Okay. And once you do that, you can use it. So because this one is independent from the notebook, it's an external file, then you can load it from very different Colab notebooks. Another way to do it, as you know, if I upload something here, when I disconnect from this notebook, all of these temporal files get lost. So what you can do is, rather than storing it here, you can store it in your Google Drive, which is mounted here. If you go up here, everything you have is here. Well,
okay,
anyhow.
thank you.
So yeah, you can do it like that. A better option from my point of view is you stop using Colab and you set up your own local framework, and in there things are a bit more flexible. Is there some other question?
Since we're talking about this, can you suggest names of frameworks that we can use on our own machines?
So it depends on the operating system. If you are on Linux or Mac OS, there is a free software called PyCharm. Which is basically, as you can see here, the Python IDE for professional developers. They have a free version and they have a paid version. So you have, I think I have it here. You have a full suite to code in Python that has proper formatting. It has help with the code. You can combine libraries, etc. Another thing I use very often, and you can also use that in Windows, is something called pip, which is useful to manage libraries and manage a development framework. On Windows, you can use, or you can use Visual Studio. As far as I remember, it does have Python. And if it doesn't have Python right now, it's going to have Python in a couple of months, because the guy who originally built Python was hired by Microsoft like last week. So for sure, Microsoft is bringing Python to their ecosystem. Is there some other question?
I had another question about something kind of unrelated. So I don't know, maybe it's not the time to ask it though. I mean, it's always about Python and you know, how to work with text files, but I don't know if it'd be better to wait to the end.
Try and let's see.
So I wanted to know if there's a function to be able to connect two different text files. So for example, to have them all in one file basically as one string, but they're all found in different files with different names. Would there be one way to go through like a directory of files and put them all into one?
You mean, so the output is a string with all the files that you can play with, or the output is one file concatenating all the other files?
For the purpose that I needed it for, it would just be that all of them exactly concatenated into one file that then I could then upload into something to use like a concordancer or to view things like this.
Okay, something that you could do, for instance, let's say, just to say something, let's say these are your files. So you have file1.txt and you have file2.txt. These are just the names of the files, etc. You have many files. So if you want to concatenate them all, what you can do is you can do for file in files. Here, rather than Genesis, you would have file. I create an empty string. And here you do txt plus equals input read. So what Python is going to do, so I'm assuming this is a file in this file txt exists here. So now we have Genesis. I'm assuming here you have file1.txt, file2.txt, file3.txt, etc. So if you iterate over those file names, you open each of them as input, you read the contents, and the contents of those files are concatenated to the variable. So at the end, in txt, I'm going to have the contents of both files. Does that answer to your question? This is what you wanted?
Yes, thank you very much.
Okay, welcome. Yeah, I think that that's also a timely question, because here we are playing with a corpus which consists of one file, but this is in general not the case. In general, you have many files and you want to play with frequencies and you want to count things across files. So if you don't care about keeping track of the contents of every specific file, you just want to play with all the text at once, this is one way to do it. Okay, finding palindromes in Python. So I hope you know what a palindrome is. A palindrome is a word that ends, if you fold it in the middle, the contents are identical. So here, these are just very simple ways to, these are just examples to deal with to play with strings. So I have my corpus here, or not my corpus, but I have my list of tokens in Genesis. I haven't modified this variable yet. So what I'm going to do is I'm going to iterate over all these tokens, and my condition is as follows. Remember this guy here. I showed this thing to you, as far as I remember, in the first session. I told you this is a way to slice either a list, or in this case a string. The first value, the colon, is the lower boundary. The second value is the upper boundary, in this case the character on the right, the last character. And if I give -1 here, it means inverting the token. So the only thing I need to do to find palindromes in Genesis is I need to invert my token and see if this inverted versions is equals to the original token. And here I'm adding something. I only want palindromes which length is bigger than 1. So let's see what I get. So DIT is a palindrome. Iwi, I guess, is a palindrome. And apparently this is it. There are no. Oh, noon is also a palindrome. Cis, etc. So if I don't want to print all repetitions of DIT, which I guess is the most frequent palindrome in English, the only thing I have to say is, rather than printing here inside of the if, I can create a set, and at the end outside I just print the set. Is that clear? Obviously, if I don't add this and I execute it, I'm just going to have all tokens with one single character, which, depending on what's your definition of palindrome, you might consider as palindrome or not. Is there some question about this?
Just one clarification. If you need to create a set, you first need to create a list, right? Or not?
No. So let's try to do it. So let's say I create an empty set. Let me call it, I don't know, my set is equals to set. If I create it empty already, and here I do my set, I hope I remember how to add elements to a set. I think it's add. If I do this, and then I print my set, no my ngraph, my set, there it is. I didn't have to create an empty list, or I didn't have to create a list at all. So the only thing I do is I create the empty set, and as I told you, the set becomes a bag. So in every single iteration, I'm going to try to drop a new token in the bag. But this bag has a filter. if the element I'm trying to add exists already there in the bag, I'm not going to add it again. And this is much better than first creating a list and then converting the list into a set. Because once again, I'm saving memory. Does that answer to your question?
Yes, absolutely.
Obviously, here I can also add, I don't know, I can have some elements already here. Like, I don't know, hi. To have hi here. So I can create an empty list. I can create an empty set. I can create a set with some elements already, and I can start adding more and more and more elements. There are all, I'm only using add here, but sets have many methods. For instance, I can ask if an element exists in my set. I can remove elements from my set because maybe for some reason I don't need it anymore. There are many operations. So if you want to find out what you can do with a set or with a list or with a string, whatever, you just go to your favorite search engine and look for the documentation, and you see every single operation you can carry out. Okay, so this is roughly what I already did. So I'm not going to stop here anymore. So some exercises that I'm not going to ask you to do, I'm just going to show them to you because we still have time, but you are not going to meet anymore, so it's not like I'm going to ask you any homework. So remember, I'm taking these exercises from Kenneth Church's Unix for Poets. I just translated it into Python, so I'm reading from that article. It is said that English avoids sequences of blah blah ing words, like suffix ing, ing. Find bigrams where both words end with blah 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 ing. So this is fairly simple to do. Again, there are many possible solutions. Here I'm just showing one of them to you. It might not be the most efficient one. It might not be the nicest one. It does the work. So here I'm using, again, the function I had defined to create n-grams. In this case, I'm interested in bigrams. So what I'm going to do is I'm going to get all the bigrams in my corpus by taking advantage of the tokens I had computed before. So here in grams, I have all bigrams. After that, I'm going to compile a new regular expression. And the regular expression is period plus ing, followed by space, period plus ing, followed by $sign. What does this mean? Period here is not a real period. It's anything, any character. So any character, I don't care about what. One or more times. That's the meaning of plus. If instead of a plus I have a star, it's 0, 1 or more times. But the plus is 1 or more times. Followed by the string I'm interested in, the suffix ing, a space, this one, I repeat. And I use a similar line to what I used before. I'm going to iterate over all my n-grams. And I think this kind of answers to the question, one question that we had at the very beginning. Like, instead of having an in, can I use a regular expression? Well, here you are. Here, rather than having a condition which is based on in, I have a condition based on the regular expression. Match is going to tell me true if this current bigram sticks to this pattern. Match is going to return false otherwise. So if I execute this, I get all bigrams in which the two words in the bigram have ing as suffix. So creeping thing, living being, living thing, creeping thing, blah, 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 blah. Once again, I can create a set and look only at the vocabulary of these bigrams. Is this clear? Is there some question?
I wanted to ask, I know it's a simple thing, but if I want to see the list of the words and for every bigram line, how you can do it?
What do you mean? What do you mean with a list of the words?
Oh, right. It's not very clear. I wanted to ask, instead of having all the bigrams in only one line, I want to break line every time there is a new bigram.
Okay, get it. So you mean about the formatting? Keep in
Yes.
mind, yeah, thank you for the question. This is not a simple question, and yeah, please keep asking. This is just a representation of what I have inside in my memory in this variable. So I can do whatever I want with this representation. If rather than just printing it, all of the n-grams in one line, I want to print only one string per line, there are many ways to do it. One of them is I can use for x in ing print x, right? And if I do this, now I don't have anymore the representation of the list. Now I'm printing every single instance in that list. This is the verbose way of doing it. The Pythonic way of doing it would be print a line break dot join, sorry, not here, join ing. And I get the same. Remember what I told you about join. So join is going to get a list as input, and whatever you give here is going to be the glue to merge every single element in the list. So in this case, I'm telling, take all the elements in this list and put \n in the middle. So I'm printing it at once. Is this what you were asking? How to?
Yes.
Okay. Is there some other question here? So here I'm using a regular expression, as you can see. Another way of doing this is using string operations. So once again, I get my bigrams. I start with an empty list because let's say I'm interested in all the occurrences. If I just want to find which of them exist, this could become a set, and that's it. So here, once again, I'm doing it, let's say, the verbose way. For every single word bigram in my collection of n-grams, I'm going to split the n-gram using a space, and I'm going to apply two conditions. If the first element, which means the first word in my bigram, ends with ing, and the second element in my bigram ends with ing, I'm going to add it to my empty list. And if I execute this, I get the same output as before. Somebody's preparing some tea, apparently with the microphone open, but I don't think I can close it. Anyhow, a question about this second version.
Here we have for gram and grams, and you don't need to define, like, introduce gram as like a variable. It already is just like, okay, I know that it's a singular in this list or one element of this list.
Yeah. Okay, if I understand the question properly, yes, of course we can do it. We can do anything we want. Maybe this way of doing the exercise is not the best one because it's not very flexible. You might have to add here per 2, blah, 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 per 3, blah, blah, blah. The thing you can do is you can create a better regular expression here to make this regular expression go and try to find instances which appear 4 times or 5 times or k times. Again, as I told you, these are probably not the best ways of doing this, both computationally and in general in terms of programming. But yeah, there are ways to do that and to kind of multiply all the matchings. In this case, it will be with this regular expression. This one has to be enhanced. It has to be more flexible. And obviously, you will have to, instead of having 2 here, you would have to use a 4 here, for instance. Is there some other question?
Can I ask another question on
yes,
the
please.
Pythonic way of doing things? Like in the line we're seeing here, like x for x in grams if regex match blah blah. Can you have another condition after the first one, or is only one allowed?
Such as?
I don't know. And the second word is not thing.
And the second word is not?
Because there were many cases like and living thing, creeping thing. So if we don't want like the second word in the gram to be thing.
Let's see. Like this?
Yes. Okay.
So yeah, the answer is yes, I think.
Okay.
You can. So this is a condition. If you want to add 50 conditions, which I cannot imagine why on earth you want to do that, you can do it.
Okay.
And you can add brackets, for instance, if you want. You can have something like this to make it a bit more clear, to make it clear that all of this is the condition and the result is going to be the same. Is there some other question? Okay, so let's keep going. I'm not going to do that here, but here there was a question of doing the same, but with ed. So the only difference would be changing this regular expression. Another exercise that I am not going to ask you to do, I'm just going to show it to you, is print verses containing the phrase, let there be light. So this is the phrase I'm looking for. Here I'm going to add it, or I'm going to store it in a variable just for convenience. I open a fresh version of my corpus because here I care about verses, and I'm assuming, and this is a strong assumption, I assume that every single line in Genesis is a verse. So I don't need to actually go and look properly for the verses. I read the lines, so I get a list of all the lines in Genesis, and I iterate. This is, again, the non-Pythonic way of doing it, let's say. For every verse in the verses, if this verse contains my phrase, or saying it the other way around, if my string, which is let there be light, appears in the verse, I'm going to print it. I want to insist, this might not be super Pythonic, but it's more efficient because I don't care about those elements in the corpus. I just want to display it, and that's it. If instead I want to store them because later on I want to do some analysis, then doing something similar to this would be better. So if I just execute this, I'm going to get all those lines. So then God say, let there be light, and there was light. And the second occurrence is this one. And God say, let there be lights in the dome, blah, 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 blah. Things to notice here. Python and any programming language, it doesn't know what is this. It doesn't know that this is one word, and this is another word, and this is another word, and this is another word. So that's why here I'm getting both let there be light and let there be lights. If I'm doing a linguistic analysis and I do care about these differences, I need to care about it. For instance, with a regular expression, or saying after this light, I want either a space or a line break or a punctuation mark. So pay attention to that, because the flexibility is an advantage and a disadvantage at the same time. If in my analysis this phrase is different from this one, I need to be very careful about what I'm asking the program to do. Is there some question? Okay, so if you don't have questions here, I'm printing that specific line in which I do have the phrase I'm looking for. What happens if I want to look at this phrase in context? I mean, I care about what appears before the line and after the line. This becomes a little bit complex. So what I'm going to do is I'm going to modify this for loop here, and I'm going to copy it here. So when I iterate over verses, I kind of lose control about what was first and what comes later. So I'm going to iterate in a different way. So instead of iterating over every single verse in my verses, I'm going to iterate over the indexes of the verses. So I'm changing this, and now the values in I, which before were assigned to verse, they're not going to be the verse itself anymore, or the contents of the string. It's going to be the number of the line. It's going to be 0, 1, 2, 3, 4, up to the end of the file. So if I want to access that specific element in the list, now I need to add the index here. And now I'm asking if my string, which is this same string here, appears in the verse, not verse, but in the verses, in the verse located at address, let's call it I. If this is true, I want to print not only the current verse, which happens to be now verses I, and before that, I'm going to print, sorry, this indentation is wrong. I'm going to print the previous verse. And if I did something wrong. It's not le, it's len. Int object is not iterable. Wait, what did I do? For I in, oh, sorry, I made another mistake. Here, len is going to give me one single number, so I cannot iterate over a number. Remember that we used range before? I need to use range in this case. And range is going to give me, it's going to be an iterator, which is going to give me all values from 0 up to the value I'm getting from len. And here it is. So let there be light. This one is this one here. And the verse appearing before that one is the air was a formless void of darkness, blah, blah, blah. This is the second instance that I have, which is the same one here. And this is the phrase appearing before. Is there any question? So I just started strip to get rid of the line break here at the end of the first verse, and now you can see it a bit better. So the verse matching my condition here followed by the former, the one appearing previously, and the second one. Question, if you don't have any question, is this code correct?
I don't understand. Well, I don't understand how length works here. I was expecting that something like len verses would return like the number of letters in the verse, but that's something stupid probably.
Okay, no, it's not stupid. Let's print verses. So print is verses is a list. Remember that verses here is the result of input read lines, and read lines produces a list with all the lines in the file. So this is what I have. It's a list with the first string, second string, third string. So if I print the length of verses, I get 1684, which is the number of lines in this corpus, in Genesis. I don't get the length of this string or the length of this other string. I get the length of this list, which is the number of items in it, the number of strings in it. Does that answer to your question?
Yes, yes.
So that's why here, what I'm basically doing here is I'm iterating, or I is taking values 0, 1, 2, 3, 4, blah, 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 up to 1684. So I'm exploring every single, or I'm iterating over every single verse in my corpus. Is there some other question? So I had asked you another question. Is this code correct?
I'm sorry, I don't know exactly what you mean by correct, like, because it does what we want it to. So in my mind, I feel like in that way it's correct.
That's precisely the point. Is it correct because it does what it's supposed to do? Sure. Is it error prone? So being correct is not only doing what it's supposed to do, it's only avoiding that this code is going to cause some error. What happens? Let me open the file. I don't remember if I can open files here. Yeah, I can open it. So let's say, so this is Genesis, right? This is how the file looks like here on the right. So let's say I'm not interested in let there be light. Let's say instead I'm interested in, where is it? Yeah, here it is. Let's say I'm interested in those phrases which contain book. So I execute this, which is not going to do anything. Well, yeah, it's going to print that one. And now I'm going to execute this code that I was asking about. It should crash. No, it didn't crash. We're going to see why. So now it does find this line, but it says the line appearing before is this one. But there's no line before this. This is the first line in the file. So what is this thing printing? The last line. And this is a mistake. This is not what I want to get. I want to get the line with the phrase I'm looking for and the one appearing before. So if I don't take care of this kind of issues, I could get unexpected results. Yes, at first sight, it does do what I wanted to do. But if we look further and carefully, that's not true. Because if this is if this becomes lower than 1, there are two options. In good languages such as C or Java, this is going to crash because it is going to say, hey, you are looking for the element in index -1, and there's no index -1 here. Instead, in Python, remember I told you, if you have a negative value here, which is, for instance, doing this, you're going to get the last one. And that's what we actually get, right? The last element in the file, which is this one, and the one with the occurrence. That's what I mean by correct. As we had it before, just like this code is not 100 correct. So if we were in a formal programming lesson, and this is part of an exam, and this is the answer you give to me, it will be wrong. You will need to say here, if I is bigger than 0, then do print the first line. And it depends on you if you want to print the other one if this is lower than 0, like saying this is the first line. So you can write something like else here. Remember what I told you about defensive programming? Else print, this is the first line. And now you actually get what you're intending to do. If, let's say, you want to do a linguistic analysis once again or something like that, you want to find co-occurrences across lines, whatever. If you don't do this, your results are going to be wrong. Is it clear now? Why you need to be very careful with these kind of things. Obviously, I can print the next one as well. I can do whatever I want. Let's say I want to print the next one instead. So I want +1. So now I need to get rid of this because I don't care. This is never going to be negative anymore, so I can print it. And I got some error. Why? Print versus. What did I do wrong? Yeah, of course, because this is not properly indented. So now I get the line after inverted and the current line, which happens to be an empty line. Once again, if we open the file here and I want occurrences which happen to appear in the last line, in the last element of my corpus, let's see what happens. Where is it? Here. So I want instances of and Joseph died and whatever is appearing later on. In this case, I do get an error because I plus 1, here I is equals to 1684. I plus 1 is equals to 1685. And the list doesn't have anything there. The end of the list is here. So in this case, I do get an error, which is an out of range error. Okay, so let me keep going. You can do many things as you wish. So here, string substitutions. This is here. I'm just revising for those in the computational linguistics corpus last year. I'm just now repeating things. So let's say I want to substitute some elements in my file. So I create a method here or a function which I call top k lines. The first parameter is the file itself or the name of the file actually. And the second parameter is the number of lines, which has a default value of 10. So if I call this function without a second value, k is going to be equals to 10. If I do add a value, let's say 5, is not going to be, k, sorry, is not going to be 10, k is going to be 5. So I open this file, I create a variable called head, and now I'm not going to read the file as I was doing before. I'm not going to use read or read lines. I'm going to use a function called next. And next simply says it's going to control the position in the file. And every time I call it, it's going to advance one position. So once again, it's one liner. It's going to be next f for x in the range from 0 all the way up to k. So what I'm going to get here is the top k lines in the file, and I'm going to return it. So here I call the function with my file as the input. I'm going to store the value in txt. And now I'm actually going to do the string substitution. For every line in my text, I'm going to replace string God for this spaghetti monster. So rather than saying in the beginning when God created heavens, now in the beginning when this spaghetti monster created the heavens. And now you can do whatever you want here. So it's just one example of replacing. So you know now how to replace things, you know how to look for things, you know how to strip a line, like getting rid of leading and ending spaces and line breaks, etc. So here I'm just explaining what next does. So in case you didn't get what's the function of next. So I'm opening again a new instance of Genesis, and I'm just calling next 1, 2, 3, 4, 5 times. So every time I call it, this is just as I said, a pointer to the different lines in the text, and I'm going to get the first line, the second line, the third line, etc. Is there some question about this?
I had a question about the use of strip in the last one. Why are there still line breaks? Is it because of the print function and it's not going to strip what the print function does?
No. So yeah, thank you for that question. I'm iterating over all the lines in the text. So to answer to that, let me uncomment this and let's print the full list. So in the full list, this is the first string. The second string is an empty one, which contains, well, it's not empty. It's a string which contains only line break. Here there is another one with a line break. So even if there's no space, if you call print without anything, let's say, let me open a new, if you do print with an empty string, it's still going to, you don't see it here obviously, but there's still something here. It's printing the empty string. So that's why we do see this empty line, because this empty line here and this empty line here are actually this one and this one, which after being stripped, they become empty, but they still have contents. So to make it clear, let me try to print, I'm not sure if this is going to work. I think it will. So let me add X here. See? I still have it. Is that more clear now? Clear,
yeah,
sorry.
So basically it deletes the line break, but there's still the element in the list that's just now empty and it just shows up as nothing now.
Correct. And print by itself does generate a line break. Just for displaying purposes. It's not like the line break is there. Is there some other question? Because this is the end of the class. There are some other contents in the notebook. For instance, this about mutual information. But I don't go to go there because I would need to explain you first the mathematical concept and then show the code to you. So I'm going to give this notebook to you, including this part. So if you are interested in computing these kind of things, you can just follow this part of the notebook and you can play on your own with it. So we still have 9 minutes roughly. So it's up to you. If you have questions, if you want me to play together with the rest of us and make some odd things here with the code, I'm here. I listen to you, and you can shoot whatever you want. Nobody? Okay, in that case, let me
Alberto, can
yes.
Since nobody else is asking any question, is there a way to do, well, there certainly is, but then to replace conditionally? So for example, using back references in Python. Say something like replace God with spaghetti monster. No, I cannot think of a way to use a back reference here.
What do you mean by a back reference?
Well, in the regular expression sense.
Such as?
Okay, I'll just think of an example and then come back to you. And in the meantime, if there are other questions, I'll just let other people speak.
Okay. So, by the way, this replace here is very simplistic because we are just using the specific strings. We are not actually using a regular expression. You can use regular expressions here, which I guess goes a bit towards your question. So you can apply regular expressions.
Yeah, okay, no, but I need to think about it more, so maybe I'll ask you later on.
Okay, is there some other question?
I actually had a question. If we wanted to replace every instance of a word, like here we just have the range 5, we would need to put in the value that is the total number of lines, or we could just leave it empty and not assign any value to k, and it would go through the whole list.
Okay, so that depends on what you want to do. If the lines have a meaning for you and you want to process every single line at a time, then you don't call top k lines, you simply call read lines, and then here you iterate over the full corpus, and that's it. If you don't care about the lines, I mean, I did this just for displaying purposes because I didn't want to print the full corpus here. If you don't care about the lines, you can simply use read, and you read the full corpus, and then you do the replace on the full corpus, not on a list, and you do it once. Well, programmatically, you have one line. Inside, it's going to go over the full corpus, and it's going to do all the replaces.
Okay, thank you.
I think you also have to you have to look at once again at the level. If you go, as there are no other questions, you can do Python string operations, because there is replace all, there are many things. So for instance, I don't know, let me try to find something. There's no replace here. For instance, here, let's see what it does. You have replace, you're going to replace is with was, and then it has a second parameter. So let's see what it does. It's replacing that first is here, but not the, okay, here in the first case is replacing every single instance of is. So there was one is here, so this is the input, is replacing this one, this one, and this one. And with this second parameter, it's replacing this one, this one, this one, but not this one. So apparently it's only the first 3 occurrences, which is 1, 2, and 3. And the 4th one, it doesn't touch it. So remember what I told you about the default values. If you don't add a value, it's going to replace every single occurrence across one single string in the corpus, talking about our corpus across one single line, or across the full file if you call it with the full file. Otherwise, if you add extra parameters, in this case this is 1, but there are many other options, it's going to replace only the first 3 occurrences. Again, the secret, oh, here it is, here's the definition. So you're going to replace the old value with the new value, and when you see square brackets here, it means this is an optional parameter, and in this particular case, it is an optional argument, which means only modify the first whatever occurrences. So you need to learn to read this kind of documentation. The signature of a function, and the parameters that you can use, and what it's going to return. Is there some other question? No more questions? Okay, so we close it here then. Thank you very much for coming. I know it's been 6 very long hours, but I hope it was useful for you. As you might have realized, this is not a kind of advanced Python programming course, but I think it's a fairly reasonable introduction that opens the door for you to go and explore on yourself, and knowing what if you face a problem in the future, avoid that you are going to say, oh, this is very interesting, it would be great to do it, but it needs programming, so I won't do it. So thank you very much again for your attention. If in the future you have any question, you can drop an email. There is